So, this task is all about using algebra tiles to model completing the square. And we have a series of increasingly difficult questions to try on the left, and then 4 completed examples already. The 2 examples on the left all just involve positive tiles, so hopefully a little bit more straightforward. And the ones on the right involve negative tiles. Now you can see the careful orientation of the tiles here. I've made sure that the positive tiles always go in the top right or the bottom left, and the negative tiles always go in the top left or the bottom right. And that mimics exactly what you might do if you're modelling, say, multiplication of directed number. If you draw out your axes, your positive products always go in the top right and bottom left, and your negative products always go in the top left and bottom right. Now for this short video, I'm just going to model this last one here. We're going to complete the square for 4x squared minus 4x minus 5. And I think it's a really good example of how sometimes virtual manipulatives can actually be better than their physical counterparts. Okay, so let's build this expression using algebra tiles then. So we've got 4x squared, and we've got negative 4x. I'm going to place those directly underneath the x squared tiles. And then we've also got 5 negative unit tiles as well. So there's our expression, 4x squared minus 4x minus 5. And now what we want to do is try and complete the square for each of these x squareds. But we've got a problem, because what am I going to do with this negative x tile here? Now with the physical manipulatives, you can't actually halve these without getting some scissors out if they're cardboard tiles, or if they're plastic ones, you just don't really have the option at all. But with the virtual versions, here's where they have a bit of an advantage. We can just click a button and we can just halve all these tiles. So this distance here now is a half and another half to make the full one. Now I'm going to rotate this round, and notice I'm still being consistent where I'm placing these tiles. I'm using the top left and the bottom right for my negative tiles, and the top left, bottom right for my negative tiles, and the top right and my bottom left for my positive tiles. And that tells me straight away that this little space here that I need to fill to complete the squares must be a positive tile. So to fill these in, I'm going to have to bring in a positive 1 tile, but if I do that, I also need to bring in a negative 1 tile. Now again, another benefit of the virtual manipulatives here is that I can just split this into quarters as well. So halve it first, and then just halve it again, and now I've got my quarters. Each of these little tiles here has an area of 1/4, and we can now complete the square to get to our solution. So our 4x squared minus 4x minus 5 can be written as 4 lots of x plus a half squared, and you can see the 4 lots of x plus a half squared minus 6. Now have a go doing it using the abstract, and you should get exactly the same answer. So hopefully you've enjoyed that, and as always, any thoughts and comments in the thread below.